So this video is about what Wilczek says about the ether. This is Frank Wilczek. He's an American theoretical physicist, mathematician and Nobel laureate, and he's a professor of physics at MIT according to Wikipedia. Now, I've an article by Wilczek saying the ether exists, and the article is called Persistence of Ether, and it's in Physics Today, January 1999. Unfortunately, the end of the article is not so positive that the ether exists. Now this is the article, and we shall now go through the article. He says, quite understandably, the ether has acquired a bad name. There is a myth repeated in many popular presentations and textbooks that Einstein swept it in the dustbin of history. The real story is more complicated and interesting. I argue that the truth is more nearly the opposite. Einstein first purified and then enthroned the ether concept. As the 20th century has progressed, its role in fundamental physics has only expanded. At present, renamed and thinly disguised, it dominates the accepted laws of physics, and yet there is a serious reason to suspect it may not be the last word. So it's interesting he mentions the word myth. I've done a video on myths of relativity, so what he's pointing out is another myth. The myth is what is normally taught physics students is the ether has been disposed of by Einstein. That is a myth, according to Wilczek. Now, there's a point of view that Einstein discarded the ether, then changed his mind and brought it back again. Getting to a relevant bit, he says, the first sentence of Einstein's original paper on special relativity refers to an asymmetry in the formulation of electrodynamics, which does not appear to inhere in the phenomenon. His paper's achievement was to highlight and interpret the hidden symmetry of Maxwell's equations, not to change them. The Faraday-Maxwell concept of electric and magnetic fields as media or ethers filling all space was retained. What had to be sacrificed was only the false intuition that motion at a constant velocity would necessarily modify the equations of an ether. So he's putting his interpretation onto Einstein's 1905 paper on special relativity. Einstein in this paper says the ether is superfluous, which most people interpret as discarding the ether, but Wilczek is interpreting the paper as keeping the ether. Moving on to another interesting comment, he says, thus in 1917, following Einstein's revelations, the electromagnetic field remained essentially in the form bequeathed by Maxwell, satisfying his ethereal equations. Moreover, space-time itself had become a dynamical medium, an ether. If ever there was one, for example, a major consequence of general relativity is that distortions of space-time can themselves produce further distortions, initiating gravitational waves. So he's saying that space-time is the ether. He then goes on to account for physical phenomena. One needs apparently more than the gravitational and electromagnetic fields. Electrons, for instance, by 1917, J.J. Thomson had discovered them. Lorentz had made impressive progress in understanding many properties of matter from a theory in which they were prime players, and Niels Bohr had used them to make his brilliantly successful atomic model. In all these applications, the electrons were modelled as point particles. As such, they constitute an element of reality quite separate and distinct from any continuous ether. Now, the theory that goes in most detail about point particles is, as I pointed out in several of my videos, Boltzmann theory, and Wilczek is not really going into sufficient detail of how point particles connect with ether. Wilczek says Einstein was not satisfied with his dualism. He wanted to regard the fields or ethers as primary. In his later work, he tried to find a unified field theory in which electrons and of course protons and all other particles would emerge as solutions in which energy was especially concentrated, perhaps as singularities. But his efforts in this direction did not lead to any tangible success. So, noting the words ethers used by Wilczek, he's thinking that the fields are now the ethers, and he's pointing out that Einstein was unsuccessful in his unified field theory quest, but there's other people other than just Einstein who are working on unified field theory ideas, and most of the time the mainstream ignores that. Unfortunately, Wilczek then goes on to say the following: how did I provoke Feynman? I asked him, doesn't it bother you that gravity seems to ignore all we have learned about the complications of the vacuum? To which he immediately responded, I once thought I had solved that one. I had a slogan, the vacuum is empty. It was then he got wistful and must have been sitting there thinking about it. This is what Wilczek says, I was deeply impressed to realise that Feynman had been wrestling with the problem of the cosmological term already in the 1940s, long before it became a widespread obsession and frustration. So, thinking about the cosmological term, and it leads you to being a bit frustrated. You have to admit that his slogan is catchy, the slogan being the vacuum is empty. So, just maybe, despite everything I said up to this point, eventually we really may have to do without ether. So Wilczek is thinking suddenly, oh, maybe the ether doesn't exist. So he's open to the possibility of what you've been saying about the ether or ethers needs to be revised. But I don't think that point of view is very helpful. He needs to be more positive and saying, according to what we know, the ether exists. But he's allowing the possibility, or maybe it doesn't. That's the end. Finished. Thank you.